In 1977, humanity launched a spacecraft that would travel farther than almost anything we have ever built. Its destination was not a single planet or moon, but the vast unknown beyond the edge of our solar system. That spacecraft was Voyager 2. Originally designed to explore the giant planets, Voyager 2 exceeded every expectation. It flew past Jupiter, Saturn, Uranus, and Neptune, revealing worlds unlike anything scientists had imagined. Even after completing its historic planetary mission, the spacecraft continued its lonely journey into interstellar space, transmitting valuable scientific data from a region where sunlight is little more than a distant glimmer. Decades passed. The spacecraft grew older, its power slowly decreased, and engineers expected occasional communication problems as its aging systems continued operating far beyond their original design life. Then an unusual event caught the attention of mission specialists. While reviewing routine telemetry from Voyager 2, engineers noticed a faint low-frequency fluctuation mixed within the normal radio transmission. At first, nobody considered it unusual. Spacecraft operating billions of kilometers away often experience interference caused by cosmic radiation, solar activity, or ordinary electronic noise. The anomaly seemed insignificant. But curiosity led researchers to examine archived recordings collected over many years. To their surprise, similar fluctuations appeared in several older transmissions. Even more interesting, the signal seemed to repeat at nearly regular intervals. Unlike many naturally occurring radio bursts that appear random and unpredictable, this pattern displayed a level of consistency that immediately attracted scientific interest. Researchers carefully measured its frequency, timing, and intensity. Although no one suggested an extraordinary explanation, the signal clearly deserved further investigation. Powerful computer systems processed enormous amounts of Voyager's historical data, comparing thousands of transmissions collected over decades. The results revealed something unexpected. The mysterious pulse appeared to become slightly stronger whenever Voyager traveled through certain regions of interstellar space. Yet there was no evidence that the spacecraft itself was generating the phenomenon. If the measurements were accurate, the source appeared to exist somewhere outside Voyager. Astronomers began comparing the data with observations from radio telescopes on Earth. Known pulsars, distant galaxies, and ordinary cosmic radio sources failed to match the unusual pattern. That did not mean the signal was artificial. The universe contains countless natural processes that scientists still do not fully understand. Nevertheless, the mystery deepened. As additional observations were analyzed, researchers noticed another curious detail. The apparent source did not seem completely stationary. Instead, it appeared to shift position very slowly relative to Voyager's path through interstellar space. Whether this movement reflected the source itself or resulted from complex magnetic conditions in deep space remained uncertain. Computer simulations explored several possibilities. Some suggested interactions between charged particles and the interstellar magnetic field. Others considered previously unknown plasma waves. None of the proposed explanations perfectly matched every characteristic of the recorded data. The unanswered questions encouraged even closer examination. Communication experts joined astronomers to study the signal using advanced mathematical analysis. Rather than listening to the transmission as sound, researchers converted its structure into visual representations. Unexpectedly, repeating geometric patterns began appearing within the data. Symmetrical curves, layered waveforms, and recurring mathematical relationships that seemed surprisingly organized. Most scientists remained cautious. Natural systems frequently produce remarkable patterns without requiring intelligent origins. Snowflakes, crystal formations, spiral galaxies, and planetary rings all demonstrate that nature can generate extraordinary order through simple physical laws. Still, the signal continued challenging expectations. Machine learning software was then used to analyze millions of possible combinations hidden inside the transmission. The artificial intelligence detected subtle regularities that conventional software had overlooked. It could even predict portions of the next repeating sequence with surprising accuracy. Researchers emphasized that prediction alone did not indicate communication. Many natural systems follow repeating mathematical behavior. However, the discovery confirmed that whatever produced the signal was following consistent physical rules rather than random noise. Around the same period, scientists monitoring data from Voyager 1, now traveling through a different region of interstellar space, identified unusual magnetic fluctuations occurring within a similar timeframe. Although the two events could not be directly connected, their timing encouraged researchers to investigate whether larger interstellar processes might influence both spacecraft simultaneously. Then something even more surprising occurred. Without warning, communication with Voyager 2 became temporarily interrupted. Mission controllers immediately began standard recovery procedures. Given the spacecraft's age, temporary communication problems were not unexpected. Yet multiple Deep Space Network antennas experienced the interruption almost simultaneously, making engineers carefully review every possibility before restoring contact. The brief interruption in Voyager 2's communications quickly became the focus of intense investigation. Engineers first looked for the simplest explanation. After nearly 5 decades in space, the spacecraft operates with extremely limited power, aging electronics, and a communication system never designed to function this long. A technical malfunction seemed far more likely than anything extraordinary. Yet several questions remained unanswered. Around the same period, instruments studying the outer boundary of the solar system detected unusual variations in the solar wind and the surrounding interstellar environment. Scientists believed these changes were most likely the result of complex interactions between charged particles and magnetic fields. Even so, the timing encouraged researchers to compare every available observation. Days later, Voyager 2 resumed transmitting. Its familiar stream of engineering and scientific data once again reached Earth, confirming that the spacecraft was still alive and continuing its historic mission. But while examining the recovered transmissions, analysts noticed something curious. Some sections appeared slightly different from previous recordings. Tiny variations in timing and signal strength were present, although they remained within the range of what could be caused by distance, interference, or normal changes in the communication link. To better understand the anomaly, engineers reconstructed portions of the transmitted data using advanced computer models. The reconstructed patterns produced unusual geometric relationships that immediately attracted attention. No hidden message appeared. No confirmed evidence of intelligence emerged. Instead, scientists found themselves studying another example of how complicated radio signals can become after traveling across billions of kilometers through the turbulent environment of interstellar space. Even so, the mystery continued to inspire debate. Could unknown plasma structures be affecting the signal? Were magnetic fields bending radio waves in unexpected ways? Or had Voyager simply encountered a region of space unlike anything previously measured? As these questions circulated through the scientific community, observatories around the world quietly collected additional observations from the same region beyond the planets. Most measurements appeared completely ordinary. However, a few radio telescopes detected faint infrared sources moving slowly against the distant background of stars. Astronomers proposed several possibilities. The objects might be previously undiscovered icy bodies. They could be extremely faint brown dwarfs. Or they might simply represent distant galaxies whose motion only appeared unusual because of Earth's changing position around the Sun. At this stage, no conclusion could be supported by the available evidence. Meanwhile, computer scientists investigating massive collections of radio astronomy data noticed occasional repeating mathematical patterns buried within ordinary background noise. Most experts agreed these patterns were almost certainly natural. Random processes frequently produce surprising coincidences, especially when enormous amounts of data are analyzed. Still, every unexplained observation encouraged researchers to continue searching. Science advances by investigating mysteries, not by assuming impossible explanations, but by carefully testing every possibility until the evidence points toward the truth. Outside the scientific community, however, speculation spread rapidly. Online discussions proposed everything from secret spacecraft to extraterrestrial civilizations monitoring Voyager's journey. Creative stories imagined an unknown object silently traveling beside the probe as it crossed interstellar space. Others suggested that humanity's famous golden record, the collection of sounds, music, greetings, and images attached to both Voyager spacecraft, had finally been discovered by another civilization. These ideas captured imaginations around the world. But imagination and evidence are not the same thing. NASA has never announced that Voyager 2 detected intelligent life. There is no confirmed evidence that an alien object is following the spacecraft. Nor has any verified observation shown that humanity has received a message from another civilization through Voyager's instruments. Even so, the real mission remains extraordinary. Voyager 2 is the only spacecraft ever to visit Uranus and Neptune. It continues exploring a region of space no human being can reach, sending back valuable information about the environment beyond the protective bubble created by the Sun. Every transmission expands our understanding of interstellar space and helps prepare future generations for even more ambitious journeys. Perhaps one day another spacecraft will travel much farther. Perhaps future technology will finally answer questions that today remain beyond our reach. And perhaps somewhere within the vast darkness between the stars, discoveries still await that will completely reshape humanity's understanding of the universe. Until that day arrives, Voyager 2 continues its silent voyage. A tiny spacecraft carrying the curiosity of an entire civilization. Every faint signal it sends reminds us that exploration is not about finding easy answers. It is about asking bold questions, following the evidence wherever it leads, and accepting that the greatest discoveries often begin with a mystery. As Voyager 2 moves ever farther into the unknown, its remarkable journey continues, proving that even after nearly half a century, humanity's oldest explorer still has new stories to tell.